Good morning. Now that we've worked with some polar coordinates, we've seen examples of curves that are not defined in our usual function notation where we've got like f of x. Also, we have curves that are not themselves functions. Most of our polar coordinates that we've seen, they came up with, we had all those curves to them, the rows, the circles, the limacon, the lemniscates, all those others. They were not functions in your traditional sense. Today, we're going to start working back towards our functions as we have them, but actually not our functions, but our rectangular coordinates. Now, we saw with our rectangular coordinates, the converting from polar to rectangular coordinates, that like we had r squared equals x squared plus y squared. We've seen with parametric equations that everything can be translated back to like the circle and rectangular coordinates. So we are going to start moving into what we call conic sections, and I'll have a little bit more talking about what conic sections are in the next few days. But first, now we're going to look through a little bit of algebra review. We're going to go through a topic called completing the square. Now, we've seen some conic sections before. We're going to get into those more next week, tomorrow and next week. But first, we're going to do a little bit of algebra review, something called completing the square. So you have what am I saying? You have a PDF with some examples there that I'm asking you to do. I'm going to go through number 1 and number 8. My background is getting all fritzy there. Let's see if we can reset. Oh no, it's not adjusting quick enough. The computer is not fast enough. You actually realize I am not on some deserted island avoiding Corona. But it is what it is. All right, so we're going to go into an example. Check it, follow along, let me know what I can help with. Now, completing a square, the whole idea behind this is, you've seen this before. We're going to take a quadratic polynomial, and we're going to switch it from standard form, that ax squared plus bx plus c, and we're going to change it into vertex form, a times x minus h squared plus k. This is going to be a useful skill working with conic sections because we get into our algebra working through a variety of kind of manipulation techniques. So this is number 1 off of the practice that you have for today. I'm going to go through the steps to see how they work. Working, we take our polynomial, our quadratic. We want to first factor out any leading coefficient, the a value from the quadratic, and a linear term. So right now, we do not have that. We just have x squared plus 6x. The next example that we're going to have, we will have that a value. First bit after that, we're going to identify the b value. That's the piece with the linear term. So in this case, it's 6. We take that, we cut it in half, and we are going to square that value. Now we're going to add and subtract this value to our statement. So there, I've taken that 9 that we have, added 9 and subtracted 9. You say, why are we going to do that? Well, what's happening here is that we're changing nothing. We have added 0 to our equation. But by adding 0, these first 3 terms, this x squared plus 6x plus 9, that is now a perfect square trinomial. So we're going to take that remaining trinomial, those 3 pieces, factor that, giving us x plus 3 squared. The remaining bits we simplified. We have negative 9 plus 5 gets us negative 4. So what's happened is we've taken from standard form up top, and we've turned this into, oh, didn't want that. Come on. We've taken it from standard form, we've turned this into vertex form. The value is that now we have a perfect square factor. Last year or in previous experience, this perfect square factor was easy to solve for. We could take the square root. We're going to be looking at, I said, conic sections where we have a variety of different curves that this will be useful for identifying our centers, our shifts, and other characteristics of our graph. So, completing a square, we go through these steps all the way along. Find the b value, cut the b value in half, square that value, add and subtract, and factor the bits that we added. Now notice the b value cut in half is 3. It is always going to be the value inside our binomial factor. It's always going to be adding or subtracting that value. If we were to multiply this out, FOIL as you would call, distribute this exponent, we would have x squared plus 6x plus 9. It's always double that product, which is what we can use for that. Next, we're going to try an example where we have a leading coefficient of a. So I'm going to go, this is number 8 off the practice that you have. Realize it says example, but this is going to be number 8. We have y equals 9x squared minus 12x plus 13. We're going to factor any leading coefficient a from the quadratic and the linear terms. So we're going to take that 9, we're going to divide it out, separate it out. This way, now it's going to behave just like what we had before, where we've got a coefficient. So I'm going to forget about the 9, I'm going to forget about the 13 for right now. Find my b value. This is at negative 12 over 9. I realize that I missed the negative there. I'll put it in later. So we've got negative 12 over 9. Cut it in half. It's going to be negative 12 over 9 squared, which is 6 over 9, which is 2/3. Now I realize we could simplify 12 over 9, reduce that fraction to 4 over 3. We would get the same exact thing. Square that value. So 2/3 squared is 4/9. That's a mistake here. This should be 4/9. I'll go in and fix it in a moment. We're going to add and subtract that value. So I'm adding 4/9. Now I'm adding inside the parentheses. I also have to subtract outside. That 9, this isn't exactly 4/9. It's going to be 9 times 4/9. So we have to do 9 times 4/9 there. That trinomial gives us our perfect square, and we'll simplify what's on the outside. I'm going to go through and adjust this. So I'm going to factor the resulting quadratic and simplify. So as we said, this was 4/9. Apparently I can't math outside of school. That gives us plus 4/9 inside, and then we're going to do minus 4/9 times multiplied by our coefficient outside. Now notice here it works out nicely that we've got 9 times 4/9 is just going to be negative 4. And so we're going to have negative 4 plus 13, plus 9. We've taken it from standard form and we've turned it into vertex form. So we have a way of manipulating an equation, working through it. Try out the rest of these. I'm around if you have any questions. Catch you later.